Alright, my apologies for it being so late. My sisters were babysitting, so needless to say, it got pretty loud. I decided to trade out the violet fluorescein for just a toothpick painted in it, so that way I can approximate a point source. I've made an aperture of just plain old soda can, or soda bottle lid, just one of the plastic ones. So that'll choke it down to where it'll approximate a point source. Here is a main objective lens to pair of binoculars, eyepiece to said binoculars, and an aspherical lens to a really powerful flashlight. I have a violet laser here for powering the dye. I have a mirror. It's glued onto a computer fan from one of my previous laser experiments a long while back. So, funny thing about these things are, these aspherical lenses, very picky about what side you choose to focus on, and that's thanks to the acceptance angle on the surface curvature of them. So, they don't work both ways basically. And for what we're doing, that overcomplicates things. These things are really, they're meant for these more niche applications. You have to have a specific goal in mind for them to really start becoming useful. And that's like these. These are the same way, just less dramatic. And another thing too is that they don't have the same magnifying power. They have a good amount of light capturing power, but not magnifying. For example, the focal length on this is 9 inches. So that brings us to a whole nother problem. Even with the sun, we can only get it to a certain size focal point. That's kind of an issue, since we're trying to basically recollimate or build basically a beam expander or compressor, whichever you would like, to focus down the light and concentrate into a narrow beam for heating, so you could do stuff like engraving or supply power to concentrated solar cell, or in my case, one of these days, building a better dye laser. I don't have the stuff to make a proper dye laser. I would need at least a foot-long piece of glass tubing and some Brewster cut glass spacers to put in it. And even then it would be really crummy efficiency if I even got those with some good mirrors and beam splitters. So there's definitely a limit. You have triplet state absorption, which really limits things. So you'll have to run the cell with a large amount of gain medium that's really dilute. That's kind of no fun. It means it's going to take up a lot of space and be very inefficient. So, what I'll probably end up doing is just showing you how one of these would work in theory and in practice. Oh, that's another thing to point out. When we're trying to take sunlight and focus it down, we want a higher magnification. Usually better to an extent though. See, the limit is because the light coming from the sun's at an angle, and it's like half a degree. It's not much, but it's still relevant to this. And like, for example, this could work, but you'd need to build a choke aperture to limit the cone of light going through, which again, that limits your total collection power. So the better way around it would actually just be to have a higher magnification lens. The problem with that, though, is of course dispersion, where you get chromatic aberration. And as one who's very nearsighted, I can very much tell you, it's kind of neat because my glasses actually kind of act like, well, a prism or a diffraction grating. If I tilt my viewing angle through these, it splits the colors on literally everything. It's pretty bad. So, but yeah. Now to a cutscene when I've got this thing running. Okay, so with the binoculars objective lens, this is the best that I can get it to go right now. It's striking this mirror, and it's coming all the way back over here. We can't see it because the light on the camera is on. There we go. That's from a pretty good distance. I'd say it's about 10 feet. As of right now, that's the best that I can do with the setup because I don't have precision way of setting things up, so it's just kind of throw together. I'm very sorry about that. But yeah, if you've watched any of my other videos, you probably know that by now. More of a hobbyist, and it's just kind of a documentary for my friends, and that's all. So, there's that one. So yeah, this beam is coming from here, exiting this aperture. It's placed at the focal point of this lens, which then strikes this mirror, and of course it's nearly perfectly collimated. And of course there is some divergence because when you have small aperture, that's just what happens. So now the only way to get better quality out of it would, to be entirely honestly, have better optics. And of course I can focus it down to a very fine point on the wall here. Just kind of looks like a white orb from there. In fact, that might be my next thing to do, is reroute it and see if I can't get a linear, very fine point beam, because I still have two other lenses from the binoculars here. And it may work, but most likely not. Yeah, I could not get it to work very well for me, trying to go further with it with the other lenses. Even more issues is that the more lenses you have, the more alignment becomes an issue. Plus, even worse, is reflections. If you don't have good anti-reflective coating, you lose up to about 4% each lens, which, you know, I don't know, say about 5 lenses, you just lost a fifth of your power. So that's no fun. That's kind of like the same problem with the mirror. I lost about a fifth of the power using a mirror to run it when I had it when I was younger. But the trade-off was, it was so much easier to just move one mirror piece that was built into a stand than to line up an entire array of lenses every time I needed to move it to adjust for the sun moving. So that's the reason for that. In conclusion, I'm not even going to pretend that I know all there is to know about it. I'm just telling you it's some of the more Captain Obvious kind of stuff, which, you know, I'm sorry about, but that's my main thing. I'm a tinkerer. I just goof around with stuff and see what I can do with it. As far as the mathematical part of it, not that great at it, not gonna lie. Don't get me wrong, I've used some pretty advanced maths for some of the stuff I've done before, but it's not one of those everyday things where, to me, it's more an intuitive thing for most things. There's a few occasions where I'll need exact maths for things, but it's not often. So, I hope you enjoyed and found this helpful in your pursuit to build a solar beam. At some point, I would like to see if I couldn't get a dial laser running. That would be nice. Yeah, have a good one.